My screen. All right, so today, what I'm going to do is we're going to talk about ER modeling a little bit. We showed an ER model at the beginning of the class. You know, I kind of showed a diagram of what a database looks like, and I used an ER model notation for that diagram. So you kind of had a look at ER modeling, but we're going to spend talking about how to build an ER model of a database. And let's talk about why. Well, first of all, before we do that, I just want to refresh your memory on our project teams. You know, to their slide just capturing who's on what team. So at the end of last class, we had some time for the teams to just get together and chat a little bit. If you weren't here for last class and you missed the discussion with your team, please make sure you connect with your team, because we're at the stage here where you're picking your data set and you're picking roles and responsibilities for the team. And if you don't engage with your team, you'll be assigned something and you might not like what you're assigned. So, you know, please make sure to get together and coordinate with your team members so that you know who's doing what to whom and how you're going to do it. All right, so that's number one. What we're going to do today is we're going to review the design process for a database a little bit. We're going to talk about the role of an entity relationship diagram. You know, why build a model of a database before you build the database? And then we're going to talk about the different attributes of an entity relationship model. It helps us know the major entities in our database. It helps us know the attributes of those entities, the relationships between those entities, and the these relationships, you know, whether it's one to many or many to one or one to one. So all of those things are reflected in the ER diagram, and we're going to cover all of that and some of the notation that's used there. So in terms of in your database that you'll be executing over the course of this project, this is what we're covering. And some of you have already concluded this, but doing an ER diagram is very different from the rest of the database design process. You know, if you're good at programming and writing Java code, you know, you may want to be involved in the part of the project that does the Java JDBC. If you're good at writing SQL queries, you might want to be involved in that part of the project. But if you're good at, you know, figuring out how data fits together and what data you need to do certain things, you know, you're more involved in the business process analysis and the entity relationship diagramming piece. You know, this is the part where you say what you're going to have in the database and how it's going to be put together. And I'll tell you the truth, this is where I spent most of my work in the database area, was defining the structure of the database and what needed to be included. And I built some interesting databases in my career, you know, mostly having to do with cellular network design and the licensing frequencies. I built a big database of frequency licenses for Cushing wireless frequencies. And that stuff doesn't make for very exciting examples. So I was looking for a good example to use for this class, you know, that you guys might have some fun with. So the example that I'm going to use for this class today has to do more with my hobby than with what I used to work at. And so we're going to do a database design of my hobby. And I'm going to ask you guys after this class, as one of your assignments, you guys are going to do a database design of your hobbies. So today it's about my hobby. Your assignment is going to be about your hobby going forward, but I'm going to show you how you go about doing this. All right, so let's talk about how you do design a database. You know, to design a database, you need to know about the business area for which you're designing that database. You need to understand how that database is going to be used, who the users of that database are going to be. And then based on the rules of the business that database, or that the function that database is going to be used for, you need to build a data model of the database. And when you build that data model, you want to build it in a form that people can understand and review before you go to the actual code that implements that database. Because, once you get to the code, it's very hard to make changes. So the purpose of this second phase, doing a data model, is to get consensus across the users of the database on how that database is going to be used. Okay, so we're going to go through that process today. Look at my data model and questions and comments. Okay, after you've got the data model, then you have to translate that into the languages that we've been working in up to this point. You have to translate it into the DDL and the DML for SQL, the logical schema that we've been working out, and we're going to go through that process as well. And finally, after you translate that into that, you go into the physical design, where it's going to be stored on disk, how many machines you're going to, how you're going to distribute it over the various machines, and all that good stuff. So that's kind of the end-to-end design process for the database, and it starts with understanding the business rules. Now, when you design a database, there are two things you want to look out for. You don't want to have repeated data, because if you have data repeated in multiple places, it lends itself to the possibility of changing it in one place and not changing it in another place, and then you get inconsistencies. The other thing is you have to anticipate what data you're going to need to answer the key questions that your system is going to have to answer. And if you forget to include some of that data, you won't be able to answer the questions that need to be answered by that database system. Okay. So you do need to avoid those pitfalls. And as I said, a good way to do that is to draw a picture and to go through that picture. Once you've built your data model, though, it's called normalizing the data model. And we're going to go through that in the next section that we do after this section, how you go about normalizing a data model. All right, but let's get started. Let's start talking about the entity relationship model. So an ER diagram, an entity relationship diagram, models the major types of things that your database is going to be dealing with. And those are called entity sets. Those are the entity sets of your database. And, as we discussed, those entity sets have relationships between them. And those are your relationship sets. And the entity sets also have the attributes that define them. Now, we've been talking about these in more physical terms. Our entities wind up being our tables in our database. Our attributes wind up being the fields in our database. And the relationships wind up being the relationships between the keys, the foreign versus the primary keys in your database and the relations between those. But first, we want to draw a picture of those things. Okay. So we start with the entity sets. The entity set is a list of entities that share common properties. And the attributes of those entities really define what those entities are. The keys within those entities are the things that uniquely identify an individual instance of those entities. So a unique member of that entity set. All right, but let's get concrete now. I mentioned that I was going to use my hobby as an example. For those of you who don't know, in addition to teaching here Monday through Friday, every Tuesday, Friday, and Saturday, I also teach karate to kids. And I also train in karate. So what I decided to do for my example here was I was going to take my hobby and I was going to build a data model of my hobby. Because one day, when I have some time, I might want to implement a database system that allows my school, my dojo, and other dojos like it to track what's going on, to manage the business. And it's a business that I know something about. So I decided to pick that one as an example because it's a little bit more interesting than cellular frequencies and things like that. So you guys might you been going through the other stuff that I could have gone through that I know something about. So here's a little bit. Here are the major entity sets that I came up with when I modeled my hobby. Okay, a karate school has karate students. A karate school is part of a federation. Everything's political, so karate school is part of a federation. I happen to be part of what's called the American Shukukai Union, Shukukai Karate Union, ASKU. But there are ones of these all over the world. So, those are the federations. And, the karate schools are all part of that. We also have teachers, that teach karate. And the interesting thing about teachers is most of them are also students. If you're a karate student, you might also be a teacher, but that's another major entity group in this thing. All of these karate students have ranks. They have belts, the white belt, yellow belt, etc. So rank is another major entity attribute or entity set here. And those ranks have various requirements that you need to meet to get those ranks. Okay. Now, that's our organization and our rank entities. We also have various events in which we participate. So, a particular school might participate in an event, and an event might be a seminar or a class or a tournament. So those are other entity groups. With the advent or with the incursion of COVID-19, some of those events have gone virtual. So those events also have Zoom info. So we have Zoom info as an entity set. The tournaments are a kind of special event because they have various things associated with them. They have brackets. We essentially have a set of brackets. You have to compete in a bracket to advance. And those brackets have matches. And at the end of the bracket, awards are awarded. You're awarded first place, second place, or third place. So these were the things that I saw, in my business, in my hobby business, that were the major things that we need to deal with in putting together a database system that would help us manage all this. Okay. Does anybody have any questions on these entity sets? Obviously, this might be new to you. Not all of you train in martial arts, but this is something that I would use.
Actually, I did.
Yeah.
I used to be a karate student. I used to take karate myself.
Okay. So you know about some of this.
Yes.
Do you see anything I missed?
No, not really.
Yeah. But that's the purpose of doing the CR diagram. If I review this, like if I reviewed this with my school or my community of karate hobbyists, they would look at this and say, oh, you know what, John, I really think you missed something. We really need this other thing that you forgot in this list. And the good thing about that is they catch that at this diagram before I went off and implemented the whole database. Okay. So, this is my first cut. These are the major things that I see as part of this karate business, this karate hobby. And that would be my first kind of reviewing that with the community to say, this is what my database is going to contain. And they would say, yes, that's pretty good. Or they'd say, hey, you really should include these other things also. But it's a good sign that, well, I'll ask again, does anybody have any thoughts on anything that might be missing here?
Not sure, but couldn't you also add another section for what kind of moves you can what you're teaching itself?
Yeah, that's a good point. That is certainly, if I decided to extend the scope of this, yeah, I could add another entity here. That's a really good choice. Is techniques. And what techniques are we going to practice? And actually, there would be a relationship between those techniques and the requirements entity that I've got here. That's a real good point, Michael. I mean, that would be something else that I might choose to add. Or I might choose to extend requirements to include information about those techniques. I like that. That's a nice example. Does anybody else have anything else here? By the way, I'm not updating this on the fly, but if I were, I'd probably add that. Any other observations? All right. So how do we represent entities in our diagram? You know, now we're back to the standard stuff. The way entities are represented is you have a box like this, and we have actually two notations that we use for entity relationship diagrams. So I'm going to be covering them both because one is the one that's preferred by your textbook, and the other one is a more traditional one that I happen to prefer. So I'm going to teach them both to you. And we're going to use the one from your textbook because that's the one that you guys are going to have to know. But anyway, the way an entity is represented is in a box like this. And the name of the entity is in the top of the box. And then the things within the box are the attributes that define that entity. And we'll get into those momentarily. But that's how you represent an entity in the diagram. And you can see in my previous diagram, you know, I kind of grayed out the attributes because I didn't want to deal with them right now. We're going to get into them a little bit later. We'll get into that stuff later. But you usually include the attributes in the box, in the ER model notation. Now, the other notation that I used earlier in the class is what's called crow's foot notation. And I'll tell you why it's called that in a little while. But the way those represent the entities and their attributes is generally the entity is boxed and the attributes are listed as things under that box. Okay? So, you know, you might draw in either of these formats. And if you know, when you guys get to your group project, if you do either of these, I'm fine. You know, however you want to draw your ER diagram using either of these notations is fine, as long as it includes the appropriate elements. Okay, so when I add the attributes to this slide, it looks something like this. Okay, so let's take a look at these. You know, we'll start with karate student because that one is a pretty major one in this whole thing. You know, that's kind of a central entity in this whole database. And that karate student needs to have some kind of unique numerical ID. You know, this is student number 0001. You know, every student gets an ID. Some of the other things, attributes of a student might be their enrollment date, their name, which might be their last, first, middle, their address, their account information, because they got to pay for their classes, you know. So, you know, we need their credit card information. That might include the card number, the expiration date, and this little number on the back of the card. We have their date of birth, their month, day, and year. We need their height and weight because, you know, when we bracket them in tournaments, weight counts. You know, your heavyweight or your lightweight, whatever. So we need that information about the karate student. For the federation, we need, you know, the federation name. We need where it's based. It might have a website, so we need the URL of that website. Now, the interesting thing about teacher is that we did all the same things for teacher that we have for karate student. But in addition to that, teachers have titles. They're very Japanese, you know, they're senseis or they're what's called senpais or they're shihans. Shihans are teachers of teachers. So all teachers have these titles, you know, these crazy titles. So we have to add that as an attribute for teachers. That's not something that karate students have. So in addition to the things that characterize a karate student, one of the things that characterizes a teacher is their title. All right, and you can see the attributes for some of these other things. I'm going to get into these in more detail as we go along. But once again, you know, these are the things that define what these entities are. You know, what characterizes these entities. So, you know, once again, I would review this. You know, I would go down to this level now. and I would get with my system stakeholders, the people who are going to be using the system. And I would say, did I forget anything? Is there anything missing here? Like, as Michael pointed out, if we wanted to include technique information under the requirement, or we wanted to break that requirement down further, we could add some attributes there. I don't know, we could look at any of these and look at what might be there or what might be missing. But we'll get into this in more detail in just a little bit. But, the entities are the things that are in white print in the blue boxes. And the attributes that define those entities are the things that are listed underneath. And some of them had so many, I had to make multiple columns. But, this is, these attributes are essentially all of the same significance. Yeah, Michael.
So underneath, like, let's say school ID, and it wouldn't, address would be a part of, it would be right underneath school name and stuff, if we were to type it out.
Yeah. I mean, eventually we're going to turn this into a logical schema. And I'll show you that step as well. But yeah, I mean, these are just attributes in that.
Oh, okay, because I thought like it was like underneath school ID was just school name, and then after that it was like address, and then.
No. I just broke it up so it fit in the various columns. Yeah, there's no significance to the columns, but they could have been listed totally sequentially. But I wanted to make all this stuff fit, and the other problem sometimes with these ER diagrams, truthfully, is finding the right drawing tool. We're using PowerPoint. There are some custom tools that will draw this stuff for you. If any of you have Visio makes it a little bit easier. But it's hard drawing this stuff sometimes, truthfully, because you don't want to make a lot of lines cross. You want to make it fit. So it's a bit of artisanship to draw these ER diagrams as well. And one of my goals for this class was to fit it all on one page. So that was another interesting challenge. All right, so that's the attributes. And the next thing we have to define are the relationship sets. We have relationships between these things. A student relates to a teacher relates to a school. We have to make those relationships clear in our diagram. So, the relationships, as we've discussed, are implemented by way of common fields. You have, in this case, we have instructor related to students. An instructor has multiple students. A student might likewise have multiple instructors. And an instructor can actually have multiple relationships with a student. I teach you guys. I'm an instructor. I teach you as students. Some of you are also unfortunate enough to have me as an advisor. So, an instructor could be an advisor to a student. So we could have multiple relationships between a pair of entities. And each one of those relationships has to be captured. Okay. So the way we represent those relationships in our notation is in the ER model notation that the book discusses. You have a line between the two entities. And in the middle of that line, you have a diamond that tells what the relationship is between those entities. Okay. So in this case, this is an advisor relationship. The instructor is an advisor to the students. In the crowsfoot notation, it looks like this. You just have a line, and the nature of the relationship, or the description of the relationship, appears on the line rather than in the diamond. Okay? Does anybody have any questions on how we represent the relationships? Okay. The relationship itself might have an attribute associated with it. So I'm going to show some examples of that a little bit later on. But, you know, an advisor may have a date which says, or an advisor relationship may have a date that says when that student was assigned to that advisor. Okay? So you might have attributes on the relationship itself. But let's look at some of the relationships in the model that I put together here, and I'm going to walk you through some of these, because if you don't know about this particular area, some of these might be non-obvious. But here are my relationships. So a school belongs to a federation. You know, our American Shukukai Federation has multiple schools that belong to it. Karate students are registered with a certain school. Okay? So they're registered with a certain school. We have this registration relationship. Karate students attend certain events. Teachers preside over certain events. A karate student earns a rank, and a rank requires a list of requirements.
So the diamonds just helping you like explain how it relates to each other.
Exactly right, exactly right. And I'm going to show you a three-way relationship here. A student needs to be certified as meeting a requirement by a teacher. A teacher has to sign off that that student met a requirement. So that certified relationship has three entities that are a part of it. Okay? So these relationships can be between two or more entities. In the case of that certified relationship, I've got a three-way relationship because a karate student needs to be certified as meeting a requirement by a teacher. An event can be virtual, in which case it would be associated with some Zoom information. Okay, you'll notice I don't have any connections yet between seminar, class, and tournament. The reason I didn't do that is because these are a special kind, they have a special kind of relationship with an event. You know, there are different types of events that can be had. So I'm going to get to how we represent that in a minute. I also didn't establish a line between karate student and teacher because a teacher, once again, is a special instance of karate students. So anytime you have something that's a special instance of something else, we represent that a little bit differently, and I'll get to that momentarily. All right. On the tournament side, a teacher referees a match. Two karate students participate in a match. One is what's called Aka, the red competitor, and one is what's called Ao, which is the blue competitor. That's Japanese for red and blue. Okay? So there's an example of two relationships between two of the two same entities. You know, you can have multiple relationships between two entities that are the same entities. You know, kind of like the teacher advises the student and the teacher teaches the student. So there's an example of two different relationships between two entities. Okay. Oh, I'm missing a line. There's a relationship medals. Where did I lose that line? Yeah, so I think it's karate student medals. I'm sorry. I'll have to look for that line. I have it on. I was trying to build this slide. I forgot where that relationship goes. We'll find that out later on. All right. So a tournament includes many brackets. Well, a tournament has brackets, and those brackets have matches, and the matches have results that result in awards. So, you know, that's kind of that area, and we'll get into that in more detail. You know, and if you were reviewing this, you might say, well, you know, John, you forgot, Professor Weiss, you forgot the relationship between match and award or bracket and award. And I'd say, oh, yeah, you're right. And then we, you know, that's something we would add over the course of the design review. Okay. this characterizes the relationships that exist in this model. And once again, I would review this and I would say to my system users, did I miss anything? And they would say, well, really, this thing should relate to this other thing in this way also. Or, this relationship isn't quite right. But, the people who would review this would help me make sure that this was correct before we went into implementation. All right, so how do we represent the attributes of a relationship set? As I said, this relationship set itself might have a set of attributes, like when the student was assigned to that advisor relationship. So, the way that's represented in the top notation is we put a box there that shows the attributes of that relationship. The way that's represented in the lower notation is we have something that's called an associative entity. And the reason we need an associative entity is sometimes we have many-to-many relationships between different things, different entities. And in order to capture those many-to-many relationships, we need to have a one-to-many on the left side and a one-to-many on the right side. And that relationship may have attributes that we also need to include. So the way you address relationship sets with attributes in the top notation is you hang that box, and the way you represent it in the bottom notation is you have this associative entity that then has those attributes. Okay, so let's see what that looks like in our diagram. Here was the diagram as we left it. Oh, there's the metals. Okay, here I've added some associative not associative entities. I've added some attributes to the relationships in the notations. Like, when a student earns a rank, there's a date associated with when that student earned that rank. When a requirement is certified, this thing had a pointer. There's a date when that student received certification that they met that requirement. When a teacher presides over an event, they preside over that event in a given role. They might be the head of that event, or they may be an assistant to that event, but they have some role in that event. Likewise, teachers referee. We have head referees and we have assistant referees in our various matches. Now, rounds in the bracket have names. Round 1, round 2, semifinals, finals, all that good stuff. And, when somebody medals in a match, there's generally a photo taken of the result of the match. So, a photo could be an attribute of the medals relationship, and it can be a thing in our database. We store photos in our database. So we capture the photo as an attribute of the medals relationship. So you can see that these relationships have their own attributes as well, and we need to keep track of those because those will go into our database design output. Anybody have any questions on this so far?
What's the two lines around the triangle? Does that mean anything or not?
I'll get to that.
Oh, okay.
I promise. Good question, and I will get to that. Okay. So, we already talked about this. You can have multiple roles. I'm sorry, multiple relationships between the entities and relationship sets. And in that case, you've got roles. Course is a prerequisite, and a course is a prerequisite for another course, and that course requires a certain prerequisite. You can have that kind of relationship between an entity and itself, even. And in that case, that course is playing multiple. That course entity has multiple roles in that relationship. It's both a prerequisite and the course that requires the prerequisite. So you can have this kind of circular type of relationship in some cases to define a role for that entity. Okay, as I said, your relationships might include two entities, generally include two entities. Most of the relationships you'll see will be binary relationships. But you do have these relationships that are between more than two entity sets, as in the case of the certified relationship that I showed on the karate diagram. And the way you represent that is, you have the relationship connected to all three entities or however many entities participate in that relationship. Hang on, Nicole had a question on the WebEx. Let me make sure I've got it. Sorry, Nicole. Nicole asks, so the ER model is a depth pre-written model so that when you write the database, it is accurate and a good representation of what your model describes. Absolutely. That's absolutely a great summary of why you have the ER model. Yep, exactly, Nicole. You want to have that representation of your database in a way that you can easily modify it before you go to press. Kind of like writing a draft of a paper, or an outline of a paper before you do the paper. That's exactly what this is. This is kind of like doing an outline of a database before you build a database. Okay. All right, so the attributes. We showed the attributes in those columns in my little boxes there. Some of them are what's called simple attributes, and some of them are what's called composite attributes. So the simple attributes don't break down any further. They can be left as they are. The composite attributes you want to break down. So, for example, a date, has a month, day, and year. That could be a composite attribute if you're concerned about each of those elements. An address, an address is probably a better example. An address has a street address, a city, a state, a zip. That's a composite attribute. Okay. You also have derived attributes. If you've got, for example, a date of birth, you don't necessarily need to store an age because you can derive the age from the date of birth. And in fact, if you do store those separately, that's an opportunity for inconsistency. What do you do if the date of birth says one thing and the age says another thing? So you need to be very careful in defining your attributes for your database, that you don't create these opportunities to have these inconsistencies associated with those derived attributes. Okay? So you want to plan your attributes carefully so that your attributes don't cause the opportunity for data inconsistency. And each of your attributes, whether simple or composite, is taken from a given domain. For example, the birth year has to be a number. My first name has to be a character string. Those are the domains from which those attributes are taken. And you guys have already had experience with declaring those in DDL, where you declare what the attributes are, what the domains are for each of the attributes. Okay, so here are some examples of some composite attributes. We can divide those attributes into subparts. We can divide a name into first name, middle name, or middle initial and last name. We can divide an address into street, city, state, postal code, and we can further divide street into street number, street name, and apartment number. So, these are composite attributes. And the way we represent those in our design is by indenting. And we can also have, complex attributes or multi-valued attributes. You know, where if you have a phone number, you may have multiple phone numbers. We can represent that by showing that as in these square brackets. Now, when we normalize all of this, as we'll discuss in the next chapter, we generally don't want to have multi-valued attributes. And we'll talk about that when we get into database normalization. We're going to have to fix this after the ER diagram to make sure that we don't have multi-valued attributes. And we'll talk about that. Okay. So let's look at that in our model. You know, here we have some composite attributes. We have addresses, we have accounts. You know, I broke the count into card number, expiration date, and CWB number. You know, we have tournament type. This is actually a multi-value attribute because a tournament may include several different events. There's something called kata in karate, which is basically forms. There's kumite, which is fighting, and there's kabuto, which is weapons. So, you know, that's a multi-value attribute. And we might have to do something with that to normalize it later on. But for now, I listed under there just to give an example. Okay. And another complex attribute or composite attribute is in the bracket, we have to specify a weight requirement. And that breaks down into a minimum weight and a maximum weight. And likewise, an age requirement breaks down into a minimum age and a maximum age. And we also have a rank requirement that breaks down into a minimum rank and a maximum rank. So all of those are composite attributes in this data model. Likewise, class times, you know, we have a start time and an end time for the class. That's a composite attribute. So you'll see those composite attributes on here, and you'll actually see the one multi-valued attribute under tournament, which is the tournament type. Does anybody have any questions or comments on that? Okay. So there are my multi-valued attributes. You can see them there, or my composite attributes rather. I highlighted them for you. So you'll see those in the diagram. Okay. All right, now this is very important. Cardinality. Relationships in an ER diagram and in a database come in four types. You know, one-to-one, one-to-many, many-to-one, or many-to-many. So, for example, a student generally belongs to one and only one school, but a school has many students. So the relationship of school to student is one-to-many. Okay. Let's take a look at some of those, actually. Okay, so here's the example from the book. You know, the book talks about instructors and students. You know, you have one instructor advises many students, and one student may have many advisors. The way we represent that in the first notation is the arrow points to the one, and the back of the arrow represents the many. The way we represent this in crow's foot notation, and this is why it's called crow's foot notation, is we have a line that says the one and a crow's foot that says the many. Okay, so in crow's foot notation, we use that crow's foot symbol to represent the many and the line to represent the one. Okay, so let's look at some of these relationships. If a student only has one advisor, we will have many students to one instructor. So the arrow would go to the instructor because that's the one in this relationship. If we're doing that in crow's foot notation, if we didn't need a date for the advisor relationship, we could just draw a straight line from instructor to student and have crow's foot at the student end and a line at the instructor end to show the instructor. There's one instructor. The instructor is the one and the student is the many in that relationship. Okay, so that's the notation that's used in these different formats. And, you know, if each instructor was only the advisor to one student, it would go the other way. And likewise for the crow's foot format. Okay, so that would be how we would represent the many-to-one relationship. So this is the one-to-many relationship. The instructor is the one and the student is the many. The instructor is the one and the student is the many. And this is the many-to-one relationship. The instructor is the many and the student is the one. The instructor is the many and the student is the one. Now, a many-to-many relationship looks like this. You have no arrows in this notation. You know, you have a straight line with no arrow on either end. That means we have a many-to-many relationship between instructor as advisor to student. In the crow's foot notation, we would have that notation. Yeah, that shouldn't say teachers, that should say advisors. Advisor. So, you know, we would have this notation, we would have crow's feet at both ends showing that this was many to many. Okay, so that's the notation we use for many to many. Okay, total versus partial participation is indicated by a double line. So it's hard to see, but we've got a double line here between student and the advisor relationship on the left side. What that means is that we might have a student in that relationship, but we might not have a student in that relationship. Okay. The way that's represented, I have the circle on the wrong side, but the way that's represented on this side is you would have a circle instead of the line, which could mean 0 to many. Okay. So that means in this particular case, we have 0 to many instructors as advisors for any of the many students.
So I'm guessing for the crow's foot, it's the opposite basically for all the diagrams.
Yeah, no, I'm sorry. Let me fix this because I want to show the equivalent diagram. Let me make sure that.
Oh, so the circle should be on the other side.
Yeah, if these are truly equivalent, this circle should have been on the other side.
My bad.
Nope, actually, my bad. Now we'll fix that just to avoid confusion. That circle to the other side. And then you line. See, that's the problem with PowerPoint as a tool for drawing these ER diagrams. As you can see, it's not ideal. That's a good indication on why you might want to consider, if you go into this as a profession, getting a custom drawing tool that specializes in ER diagrams. There we go. All right, so you know these are the equivalent. These are the equations now. So let me make sure that's clear by switching that there. Oh, and let me share my screen for the folks on WebEx. And share it. Oh, that's a slideshow. Here we go. All right. So ternary relationships, you know, you put the arrows from the relationship I'm going to hold off on that. I'll show an example of that in a minute, but let me go to our diagram here. This is what our diagram looks like. And the other thing that you can do to make some of this stuff more explicit is you can put the cardinalities in numeric form on there as well. So you can say one to many, etc. I've added that here just for the sake of explicitness. This is another notation that you can use to show the relationships. But in addition to that, I have the arrows that show the one-to-one versus the one-to-many. So you'll see that on my diagram, and we can walk through these. A school belongs to one and only one federation. A federation has many schools. An event is sponsored by one and only one federation, but a federation sponsors many events. Karate students attend many events, and events are attended by many karate students. So you'll notice there's no arrow involved in that attends relationship. Okay. Likewise, a teacher presides over many events, and events are presided over by more than one teacher. Okay. A teacher might not preside over any events. So, we can have a zero relationship there, and, we have a double line there. Okay. So, we could review each one of these things individually. And, if I were designing this system for my constituents at the karate school, I'm sorry, did you have a question, Nicole? I'm sorry, sorry. What is the benefit of having a zero? The benefit of having a zero, good question. Does anybody know why we might want to know whether there's a zero there or not?
You can tell if they're actually related with it.
No, not quite. I'll give you a hint. It has to do with a property that we talked about when we talked about databases. And it had to do about cascaded deletes and cascaded. So referential integrity. The reason we have a zero there is it lets us know that even if we don't have an event, we could still have a teacher record there. Okay? So we don't want to delete any teacher records that are associated with an event when we delete that event. Or, we don't want to delete, we don't want to, if an event does not have a teacher, we don't want to delete that event just because it doesn't have a teacher. Okay? So these zeros help us understand where we might need referential integrity and where we don't need referential integrity. Question. All right, so we draw this up and we get our relationships and we go through our relationships with our constituents and make sure that they agree. Like for example, I will say that every match has one and only one karate student that will be the blue competitor. And every match has one and only one karate student that will be the red competitor. Okay? So, we can go through that. And we can say that, actually, I think I do have an error here. I think we could have a karate student who competes in multiple matches. So I should probably change that. But, we can review that and we can catch those kinds of things. So we reviewed the cardinality of these relationships with our stakeholders as well by way of this diagram. All right. The next thing we have to do is we have to identify what the primary key is of each of our relation sets. What is it that will uniquely identify an instance of that relationship set? And the way we represent primary keys is by underlining them. So you will see the primary key for each of these things underlined here, and I've highlighted them here to offset which ones are the primary keys. But generally speaking, for this particular database, I want to make sure that I have a unique identifier for each of the records in this database. So I've highlighted all of the primary keys in this database, by underlining them. And I'm using numeric IDs to uniquely identify each of these records. Okay. So we have to be able to identify a unique attribute or set of attributes within each entity set that uniquely identifies individual records within that entity set or individual instances of that entity set. All right. So for relationship sets, we likewise need to identify what the key is for a relationship set. So let's look at our relationship sets here. Get back to that. So for example, if we have an event, now let's find a better one. We have a teacher presiding over events. So we can have multiple events presided over by multiple teachers, and any individual teacher can preside over multiple events. So for the preside relationship set, the thing that uniquely identifies it would be both the event ID and whatever ID identifies the teacher. And in this case, a teacher is a specialized instance of a karate student. So for the preside relationship, we would have a karate student ID that would identify a karate student who happened to be a teacher. And we would have the event ID, and those two things together would be a primary key for that relationship set. Okay? And we've done this before. This is nothing new. We've talked about what the primary keys are for these various things when we were talking about them in terms of the logical schema. All right. So weak entity sets. This gets into Mike asked earlier, what does my double line mean around the box? So a weak entity set is a case where something is related to another entity and uniquely identified by that entity. So an example would be, where we have a section of a course that's related to a course. Like this is section 01 of 213. If there were section 02, we would have a list of sections. So in order to know what specific section we're talking about, we also have to know the course ID. Okay? So, the section in that case is a weak entity set. In that, to uniquely identify it, it depends on another entity key. Okay? So we need to represent those in our diagram as well. And the way that we represent them is we have those double lines around the relation that show that something is a weak entity set dependent on another entity. Okay. And we have a couple of those. In order to identify, a bracket is a part of a tournament. A bracket is a weak entity set relative to a tournament. A match is identified by the bracket. So the match is a weak entity set relative to the bracket. And the Zoom info is dependent on the event. The event ID has to identify what Zoom we're talking about. So the Zoom info is a weak entity set related to event.
So it just depends on if field one would include it.
Whether the other one is necessary to, essentially identify. Yeah, Nina. We'll talk about that when we get to the. I promise you, I'll get to that question. We'll get to that when we map to the logical schema. Okay. In fact, at the end of this, and I'm not sure if we're going to get through all. We're not. Let me put it another way. I'm sure we're not going to get through all of this today. In our next class, after we finish all the notation stuff, we'll get into how this maps into a logical schema. So I actually have logical schema corresponding to this diagram. We're going to walk through how we get from the diagram to the logical schema. All right, specialization. These are the lines that I kind of held off on putting in. A specialization of event is either a class, a seminar, or a tournament. And a specialization of a karate student is a teacher. A teacher is a very, a specific instance of a karate student. And the way we represent that is we have these things, these lines directly without any relationship in between them. Okay, so, this is how we specify specializations. And, there are two types. There's overlapping specializations. Every student or employee and student, somebody can be an employee and can be a student. And then there's disjoint, where the specialization is unique. That you can't be both an instructor and a secretary in this particular case. Okay, so there are overlapping specializations and there are disjoint specializations. So the specializations in my model, are that a teacher is a karate student. So they have all of the attributes of a karate student plus a few additional specialized attributes that make them a teacher. And these events, seminars, classes, tournaments, are all events that have some things that they need in addition to what's in event. Okay, so those are the specializations in my model. Any questions on that?
Would you be able to tell if it's a specialization or if it's just like the one-to-many arrows, like?
Yeah, so what's missing from these lines here? What's missing from these lines? We don't have a dynamo. That's how you tell. Any questions on specialization? Okay. Let's see. This is probably a good place to stop for today. What I'd like to do next time is we're going to continue in some special cases of ER diagrams. And we're going to finish up by saying how we map this diagram now to the logical schema that will implement our database. So that's how we're going to finish up in the next class. I'm going to pause here and I'm going to go back a little bit here. And I'm going to remind you, first of all, here. So I just want to go over what we've got going on right now. Let me find our Canvas page. So you guys should be meeting with your project groups. So you have an assignment that's due tonight. You have your intermediate SQL queries that are due tonight. So please make sure to get those in on time. Oops. Yeah. There we go. So you guys have your intermediate SQL queries that are due tonight. Get those in on time. Next week, next week you've got your group has to select and define the roles and responsibilities. You have to select your data set and define your group roles and responsibilities for the group project, which is basically doing the soup to nuts database design. So I need you to select your data set and define who's going to do what in the group for the group project. So that's due next week. We're going to have an exam Thursday of next week. And, that would be here in class unless you've been notified otherwise. And then after that, you've got your JDBC program due. And then the following week, you guys are going to get an opportunity to do an ER model similar to the one that I'm doing for my hobby. You're going to get an opportunity to do an ER model for your hobby. So, start to think about it. Start to think about, what you want to do for that. And, refer back to these slides so that you know exactly, what needs to be there. And get thinking about your ER model. And remember, the ER model is going to be the first piece of your group project as well. So it's a good time to get practice with that. All right, I'm going to end class there. Does anybody have any questions or any comments? Any questions on schedule? All right, we'll pick up with ER diagramming on on Thursday rather. Tuesday, yeah, on Thursday. We'll pick up with ER diagramming on Thursday and we'll show how that converts into a logical scheme. All right, that's it for today. Thank you very much, everybody. We got, let's see, 8 people on the WebEx today. I'm going to stop the recording.